Now let's focus on the uh, non-local and the closures. What is this closure and how different is it for a inner function? Yesterday, I told you what is a inner function. Means like within a function, if you have another function, that is called as a inner function, right? Outer function you have, within that outer function, you have an inner function. So this is fine. Then, sir, so what is the closure? How it will be different compared to this? If I go further, closures are like not just unique in Python. This is a common pattern. So which is across multiple languages. What is a closure means like? Till now, we have a use case where the outer function is there, inner function is there. And from outer function, we cannot execute the inner function, right? I told about the concept of the others, but if I have two functions like this, outer function and inner function, if both are like in the same way, means both are outside, right? Now, if I make a call, I can make a call to the outer function. So if I execute, and Python 029. Did you see the outer function is executed? In the same fashion, I will go for the inner function. So though the name is inner, but it is outside, so it is working. What if you give an indentation level inside? Then it should execute it. If you see now, it will throw an error that, hey, cannot execute the inner function. So this is a common thing. So if you remember, so if you are from languages like Java or somewhere, you might have something called as a private variables, which you cannot access outside. There should be a proper way to handle, right? So you can imagine the same scenario. Maybe like if you want to give access to a use server for someone, so then we need to validate from some kind of conditions. All conditions you can validate in the outer function, then you can give the access. Okay, sir, we may give whatever the way. Then how to execute the inner function? Till now, we know that inner function can be executed within the outer function. If I execute like that, then it will work. But from outside, we cannot execute. Is clear? Now, so what if I assign this result to some variable and execute it? If I'm assigning this result to something, the outer function, not just calling, but assigning to something. If I do like this, then what will happen? The outer function, what is the return value from the outer function? It is none. So that's why the result is a none. So though you are calling the inner function, you are not returning it, right? Now let me go for a use case. Let me make it a mark. Like instead of making a inner function call, I will do the second case where I make the return of the inner function call. Observe very carefully. From inner function, what is that we are returning? We are returning a string called as something. Now, when you are making a return, what will happen? You will get the same answer, right? If I don't clear and if I execute, say Python 029, did you understand that the result is a string right now? And you got the result as something. Means whatever the inner function is returning, that you are getting outside. So if you want to do some kind of validations, and you can run that query such that the inner function will be executed. Okay, sir, this is also good. Now let me go for the third case where I don't want to return this execution result, but I want to return the inner function itself. This may look strange, but this will be very much interesting. If I execute right now, did you see what happened? The return is again a function. If you observe carefully, this is what is called as a closure. So if you see here, so the logic is like this. So I think like here I can display for you to better understand. What is this saying? Outer, in braces, you have some kind of relation, and within that you have a inner. Means from outside, this result is having a value. So which is the outer function, right? From outer function, you made a call. That outer function is further making a call to the inner function. That's the reason it is returning it. Means Now you didn't get a result which is a string, but a function again. Means this result is another function now. So how it will be possible, sir? Means that is what. If I make a call to this result, observe carefully. If I make a call to this result, this time, it is executing, but we are not making a print from it. So I can make a call to this result. So I can place this result within an f string. Say, I can say like f string equal to like this. In this way, if I do, did you observe that the result is a something? Means it is same like outer function till now we have executed, right? Outer function. For that, if you pass one more call, that is what? So means outer function is resulting something, which is a function. For that, as it is a function, if we are passing a call, then it is executing. So both will exactly work in the same way. To prove that, let me place an f string and do. So both will give the same answer. So just to know, like for every time after everything, I'll make a empty print. So the things will be clear. Did you see now? Each time when you are making a call, you get the same result. And again, you get the same result. Means whenever you make like a result also, you get the same thing. Or like outer of this also get same thing. So what is the concept of a closure? Means like whenever you have like multiple things to execute, sorry, whenever you have an inner function to execute, generally inner functions cannot be executed from outside. If you create some kind of interface for accessing the inner functions from outside, that is called as a closure. So earlier we couldn't execute the inner function directly, but we are able to execute now the inner function indirectly. So this concept is called as a closure. Hope it's clear. So now coming to the closure further, let me go for like one more example for you to understand. Within the closures, if I go further, dot py about the closures, say I have multiple functions within the things. Sometimes it doesn't mean that you should have only one function within this. You can have multiple. Say in this case, I have an outer, which is taking an argument also. Within that, we have some numbers and we have two inner functions, not just one. Within these two inner functions, if you want which one to be make a closure, that we should decide. Let's say I want to mark this one as a closure. Then in the outer function space, we need to return that function. Means whichever the function we are trying to make an access for outside world, that is called as a closure. Because for if one function, there will be only one return. So you have written differently. So whichever is becoming the return, that will be happening. Assume that, if you take a random number or today's date, or like if you take some input, if they say like the input you're taking, number one, if number one percentile two is equal to 0, you can say like a return this one as a thing. So in other case, we can say, so return, so hello world. Hello world. So now what will happen in this case? Which one is the closure? So for a particular thing, only one return happens. Once a return happened, that is the last statement. So based upon the number that you are passing, it will have a condition and it will execute, right? So now if I say, so outer function, if I make like an outer function. So for outer, it is taking some argument. If I pass 10, if I execute CLS and Python 030, did you see nothing happened? Because outer is returning something which you are not able to print. If I use like an F string, so now you can notice that outer is getting a function which is like this. So this is one case one where you have executed. Now I want to take one more thing. Say like I am taking like 11. Is 11 an even or odd? So we should get correspondingly, right? So whenever you are giving that corresponding thing, you see, you got the answer. So whatever the number you have given, you are getting the logic correspondingly. So now you see, you have defined two functions, you have made two returns, but you only got which one. So which one is finally exposed, that will be a closure. Of course, this is a very bad idea to do because you will be very confused, right? Which one you are exposing. But sometimes you may have a logic. Maybe like you take the user. If the user is like an admin, so you give all access. Or if the user is like a developer, you give some kind of access. Maybe you can have multiple separate secret functions or like protected functions, and you want to expose the corresponding thing based on the role. So whichever the use case, there is nothing wrong to say. Now the point is like I will add, so within this logic, so about this closure. To understand which one is a closure, we can ask within it. So in both the cases, I will ask, hey, which or is the closure? So I'll try to ask, maybe like I'll place an empty print. So I'll place a slash n here, slash n, such that it would be easy for us to identify. You see, in the first case, we know that, it is like, outer dot wrapper. Wrapper will be the closure. Then in that case, in the closure you got, so for wrapper closure, if I am asking, you got an answer. For hello world, it is saying empty. But in the second case, as hello world is a closure, for hello world, you got like for the wrapper, the other thing. So whichever you placed, you are getting it. Wrapper function. But generally, this is a very confusing logic. We should never do this kind of way. So we should make only one thing. That is the best thing. And outside, if I ask for both of them, you can see. So outer is not a function which is a closure. The inner function, which is getting exposed to the outside world, that is called as a closure. So now you understood about the closures. So the last point I want to mention is about currying. So generally, currying is like a technique uh, which is commonly used in like JavaScript, currying. So this is one of the advanced concept of functional programming. So not everyone may know about these things, but it's okay. So the point about currying, what we need to understand is it is slightly same or similar to this one, but with a slight difference. So in currying, let's say I have an outer function. Within that outer function, I have an inner function. Inner function is returning something that the inner function you are exposing. So don't you think it is a closure? The same closure, right? So if you make a call right now, so from outside function, if you make a call, it will take that argument and place it. And when you pass the second function, it is taking the second one also and using. Now, now coming to the concept of, currying for the lambdas. Currying means like combining two things. That's a simple thing. So closure is a currying function. So one way. If I take like one more example, you see here, add is a function which is returning this value. This is also one kind of currying. Means the result of one function call will be another function. So to combine the total results. So means like you have first one is like 5. So the second one would be the 3 and you get like the total result. Or one more example. Say like you remember we did like partial functions. Partial functions is another kind of currying. So means like you have a multiply by x. So whichever the value you pass, it will take. And in the inner function, you're taking the next value and you are multiplying. Now the point is, first, if I make like a logic, say I'm going to multiply by of 2, then it is a double function it will create. And for that function, if you pass one more argument, it will do. So don't you think it is same like, functool.partial? Similarly, currying means like, as I told, combining. So we can have like multiple examples like this. So if I say the same currying with lambda, so instead of you defining an inner function explicitly, you can return a lambda also. This is also one kind of currying. So these are all the different ways I want to show you that. And the same currying we can do without this. So the final example I want to show is this thing. See here. In this example, what you can notice. So we have a compose function, which is having an inner function. It is taking both of that and executing the inner function with that x. So observe very carefully. It is taking like first function, second function, both the functions in the first one and the arguments in the second one, and it is executing. Now, if I have like a squares, generally this kind of pattern, currying pattern, we use whenever we are going for data engineering jobs, where you want to apply like multiple things on the same, you do it. So assume that I have a squares and additions. I want to do squares and addition also. So then we see here, in compose, I am passing two functions. So first I'm doing add and then I'm doing square. Now, if I pass one value, then what will happen? It will go first to that one and get the result. Means for if I pass like 3, 3 plus 1 is what? 4, right? I think like same logic it is executing something. So I need to see. So it is passing like first function of second function. So if you see in this case, yes. If you see in this case, f of g means like, so f means what? Add of square of that given x. So what is x here? 10. So first it will do the square of that. Sorry, 3, right? Yeah, 3. If I pass like 3 here. So 3 3s are 9 plus 1, 10. Exactly. You got the same answer. Now the same thing can be implemented with functools partial also. So you implemented the same function which will return it, and you were defined with a partial dot so and so. You execute it. So this is all about the currying pattern, which I told. This is all about the evolution of different kinds of functions, starting from the very basic to very advanced. So hope you got like a good gist of the functional programming in Python. Python is like super good after Haskell. If you know about the functional programming, Haskell is the best programming language. So if I say about the Haskell programming. So if you make Haskell is one of the other languages. It is very good in terms of the functional programming. If you compare your Python with that, so you can understand a lot. So it is also like a all features of the Hashells almost we are using in Python. Now I showed everything to you. Next, the next big thing about this is about decorators. I created like a separate chapter because it is very interesting that you will learn now. You see, first of all, why we need a decorators and what is the purpose of it? If I can say, first, let's say I'm having two functions. Some logic I am gonna do. I have two functions. If you observe, they are very simple functions, doing addition and here doing a division, right? All good. Now, if I want to use it, what is that I can do? So I can do like add of 10 comma 20. Good. So, or like I can do like add of something else also. So if I execute it, 08 and Python 00. You see, it executed, but I didn't get anything. If I make some print statements, I will get it. Let's say in this case, the interesting part I did is like I placed 4 kinds of additions. So did you see here one interesting? I have 2 numbers I placed. So plus operator can work for all same data type. So either if you have both integers or both strings, it will work. Let me comment these two for a moment. If you execute, you get both the results. The first one is like an addition operation. The second one is a string concatenation. Don't think like adding 2 numbers will become 1, 2, 3, 4. It's just like thinking 2 strings and combining them together. But at the outset, if I go for this one, it will throw an error. So it is throwing an error. What is that error it is saying? Hey, I cannot add an integer and a string. Means it didn't even go to the next one. It broken whenever you got an exception. Similarly, let me comment these two for a moment. So I will go for like one more example. So in this example, I'm dividing. When you're dividing, both are like fine. So when the numerator is 0, that also it works. But when denominator is 0, then it will be failing, right? Because of zero division error. So now you understood here it is failing because of zero division error. And here they are failing because of type error. If I'm not, if I execute, they will be failing with respect to the type error. So for both the things, the same error, right? We cannot do. Now, how to make your functions in such a way that it can handle the exceptions? So means like, do you want like another function to do these things? Or like in the same function you want to do? So means in this function, you want to make the change, logic a bit change. So what I will do, instead of doing it directly, I will write with the try exceptions. So means like what? Instead of this, I will do like this. Means instead of a simple addition, I will do the logic of addition here. If there is an issue, it will return that exception. If everything is good in the else condition, we get the result. Now, if you see in this case, I handle both the things. If I go further, did you see what happened? In both the cases, the code was not broken, but whenever it got an exception, it is returning that message. But did you see your code was working fine? Similarly, for the division. So division also, we need to solve the problem. How I will solve, you see. If I go for the division, so here also we have a exceptions. So how to handle this try exceptions? So instead of doing like this division, so we can do with the try exceptions. So if you see here in the try, I have the result. And if there is an exception, I am returning the exception. Else I am returning the result. So now if I execute the last case also, you can notice the difference. So now you are able to solve these two problems. So with the try exceptions. Similarly, now if you have multiplication, division, sorry, minus, subtraction, anything you can solve. But after solving these problems, did you notice that there is some part of the code which is common in both of them? So what is the code which is common with both the things? We understood that in both the things, the try exception mechanism is common, right? So in that case, we can do it. So what is the purpose of a decorator? Till now, we have some logic which is repeating. For repeating logic, we can write one function and reuse. But what if you have more than one function which has some part of the code which is common? Means not completely common. If completely common means you can use the same function, right? Means in both the functions, some part is common. In those cases, we can use a decorator. So using decorator, how do you solve this problem? That I will tell. Now let's take the same example. So I want to solve this problem. What I will do, hope you remember this concept of, try exception. So that is what actually happening here. I want to implement the same. I have these two functions. I will try to get it to understand how it is working. So to prove that, so I want to solve without these try exceptions, right? To generically understand and create one function which can handle these two. So I can write what? It has something, say like define. What it is doing, I can write like an outer function, or what it is doing in both the cases, it is doing a exception handling, right? So exception handler, maybe exception handler I'm writing. So in both the cases, it is doing the same logic. So can I place that common logic here? What are is there? Fine. But the point is like, we need to have these variables also passed and values also passed, but directly we cannot execute. So what we need to do, same like that. First, we need to have an outer function. So from outside, we should not call. We need to have an inner function. See, whatever the logic we did, the same thing I'm writing. Observe, this is very much interesting. So this is how we execute. So you don't know like how to pass these arguments. As of now, first make it like an empty result and it will execute. And you know how the closures work? You return that inner function. This is how only you return that thing, right? Exception handling and all these things. So means like you need to do some kind of to do. Assume like, I'm writing the to do that, I need to implement this add and so and so. So what is that I can do? I understood how to write this exception, right? So fine, there is no point. We can leave it. So now how to make the call to this function? If I do like an outer, so it can execute it. CLS and Python 01 so and so. It won't do because you are not making a print statement. Now, if I make a print statement, if f strings, so now did you get like it is a closure? Superb. It got a closure and everything is fine. Okay, good. Now, if you make a call with these values, so as you know about the outer and outer rod so and so, I can do the same things as we know till now about the outer and the inner. That's what happened. In the same fashion, we can make a call to it directly also, right? Or assign to some variable and make a call. In both the ways, we can call. In both the ways, it is going and it is returning things. Some way we need to handle this issue, we understood. So now coming to this case, we extracted the common piece of logic which you need to go. For this function, how we can do is like, instead of these functions, we can remove now. Now no more we need them. So how to handle that? If I can see, I have these functions which have some common code. For this common code, if I need to re-implement further, I can slightly change. Means I'm taking the same function, but making a slight change. I want you to see the step-by-step evolution, how I'm going. So this time what I will do, I'll place it here. I will pass like one function called as func. And I will pass the same function here. See, observe carefully. Whatever the function I passed, that function will go. So instead of printing. So the same logic, whatever is happening, it will execute, but with a slight difference. So now let me take this one example of an addition, how it is addressing it. So you have typically like till now one function which is going. So let me introduce a smaller version of this one. Say return addition. This is like a small function, right? Ignore about the division afterwards. Now I want to part this function. Observe carefully. For outer function, I'm passing this another function as an input. Now, when I make a function call, did you see that it came nothing? If I assign this to something else, so maybe like I'm saying that result add is equal to something, and I'm asking, hey, what is the value that you have? If I make a call, did you observe what happened? The result add is equal to what? It is a function which is an outer of inner, it is saying. Means from the outside, it will take and it will execute. But if you want to execute it further, I can make the same thing, right? See here, I'm placing one more brace, then it will make a call. So this is how it works. Means from outside, when you make a call, did you see that the function is coming? What is the function? Addition function. So means like the addition one we can execute. Similarly, if I make like a division also, define, say division also if I make, say like define division of, say n1 comma n2, you can return n1 divided by n2. Fine. For this also I can specify these things where I will specify the outer of division of so and so. I get the same answer like division. Now I will go in the evolution, one slight more difference. Instead of just printing that in the previous, here we are not doing anything. So now we will make something interesting. So means like we need to pass some arguments also here and we will make a function call. Observe, for any person who is creating a decorator, this is the first problem. That's why it took this much time. In the first thing, we need to pass the function. Second thing, we need to pass the arguments. So it will work like that and it executes. Now, if you make a call to it explicitly, saying like if I say just an outer of this inner, then it will become a closure. For that, we need to pass the arguments. Earlier, we passed only one argument, but this time it is taking two arguments. So we need to pass the two arguments. It works perfectly. You got like outer of this of so and so. Now the beauty is like not just for one, it will work for all the scenarios. You see, I am taking the outer of in and I'm assigning to some variable called as result add. So, and I will do it. Now, did you see that whenever the issues are there, instead of breaking the code, it is returning the exception. When everything is good, it is working perfectly. So means like what we need to understand, as I defined the outer function of the inner logic we can execute. Outer function of add and you pass these arguments. This is same as you assigned a temporary variable and you are storing, right? For that you are using like that also it is same, or directly passing this also same. But this will make a difference whenever you are going the exception handling. So this is one explanation about the decorators, how it works and others. So the next thing, now making it much more generic enough. So we understood that this is doing an exception handling. So, but let's make it much more generic enough. So how to make it a generic and how it will be useful? If you go in this scenario, earlier we have got this is the final result, right? So now we understood that it is for the exception handling. Exception handling. But so this is called as a decorator function. What are the function? This is called as decorator function. Means this exception handling is a decorator function. But so here within that we are doing a logic. Maybe I am taking this term another function called as a div. The same division we are doing, which is taking two arguments. Good, it will be working perfectly. And now how do you call this? As it is not an outer, I will make an exception of, I will pass the div function. So means like, so div with exception handling. Div with like exception handling, like that I wrote one function. Now for this div with exception handling, I can pass like 10, 12. So if I pass something, I should get the result. Here and Python 02 so and so. As you are not printing anything, you don't get anything. Say, if I make a print statement with f of so and so, now we get the answer. So the beauty is like I can do the same for all. Maybe like I am placing the first value as 0 or the second value, which is denominator as the 0. In both cases, it works. So let us say these two are good, but this is an exception handling. Did you handle that? No, but it handled perfectly. So earlier, you remember we have an addition also, the same thing. But this time, let me make this addition, say something more complicated. Maybe like I say n1, n2, so n3 I'm giving, and I want to return these values. Return n1 plus n2 plus n3. So how do you make the call? Same like add with exception. So that's what you want, right? Is equal to. So you need to pass this to this exception handling function. For that, we need to pass our function. Means function is going as an input to another function. So if I make a call to this, say like if I say addition, right? I should not pass two values. I need to pass now three values. So it works. But if you want the result, we need to print it. Oh, before even printing, the code was broken. Why the code was broken? If you observe carefully, it is saying that this inner function is taking two positional arguments, but three were given. Means whenever your function is executing, it will go here and execute. This is where your function will execute instead of executing directly. But here you are passing two arguments. Okay, let me make it like a three arguments then. Say like three arguments now. If I pass like three arguments, it should work, right? Let me execute. Now the first one is failing. Means earlier we did a division with two arguments. That is failing it. It is saying that I need 3 arguments, but I got only 2. Now, how to handle both of them? Okay, we can mark the third one as like a default. Assume like, if you are making it as a default or something. For addition, default of 0 is good. For division, default of 0 is not good, right? So then how to handle these things? Okay, if I handle that also, if I do, that is another problem. So, and tomorrow, if I get like, 4 arguments, 5 arguments, or 0 arguments, how to handle it? So this is not a correct way. So the correct way is like, instead of doing like this, we should handle it with a variable number of arguments. Hope you remember about the variadic functions. So variable args and variable keyword args means user can pass in whatever the arguments they can pass. So you need not worry about that, and you can just pass these things. Now what happens? No matter what you give, it will work. So for division also it works. Then for this exception also it works. But for this here we need to write. So like a print statement, print of f of within the strings we need to do. You got your result? Addition with exception, something. So that is how it works. So now the same thing, if you pass with the different values, say like, if I make like one of them as a string, as I have double quotes around, I'm using single quotes. If I'm making here double quotes, one of them is single quotes. If I execute, did you see? The code was not broken, exceptions were handled. This is what is about a decorator, how to use it in different scenarios. Now, the next thing that we'll learn is about the syntactic sugar of the decorator. The same decorator we use, but instead of this much. So till now you understood how to do an exception handling with a decorator. But in reality, every time if you want to pass, it would be difficult. And on top, if you want to pass like different handlers, so not every time users are aware that we need to use exception handling. Maybe in future you will have something else, 2, 3, 4 types of decorators. Then how to do? So here now to use exception handling is depending upon the client, means the user of the function. What if at the generation side, if you place it, so things will be much better. What do you mean by that, sir? Means let's take about this concept of syntactic sugar. So syntactic sugar means like we will change the syntax slightly different. The same logic, whatever you are handling, exception, everything I will store, but the logic will be slightly different. So means like, um, if I take the previous example, so entire example I will take and I will place, but this time I will use the logic in a slightly different. I have this exception handling as it is. I have this div function as it is. You are making a call, that is also fine. So let me remove this part, a division. So let's see. Now, instead of doing this division directly like this, I can do a slight difference. Means on top of this thing, I will write this exception. I just write this with at the rate symbol and this one. This is called as the syntactic sugar of the exception handling. So if I use it, what will happen, sir? So now you need not use this variable called this one. You can directly make a call like a simple div function. How we are using div, the same thing we can use. Say a div of like, what, 10, 12. So observe carefully now. If I make the first one as 0, that works. If I make the second one as 0, that also should work. So clear and Python 03. Did you observe now? It's working perfectly. In first case, what we did, so who did it? At the consumption side, right? It's at the consumption side. Consumption means like usage. So in the usage side, we handle the exception handling. But here at the production side, means at the definition side itself, Definition side itself, we are defining. Now, let's say for the exception handling I want to do, and for something else also I want to do. I need not worry. So whenever I'm defining itself, I define. But when I'm just using like an ordinary function. Now, no matter what happens, it will handle the exceptions. So now, did you understand this concept? Now let's take the example of the addition. Addition also we have done, right? For two arguments or three arguments. Now let's take the same example, addition. So for addition, how we need to handle? As we already know exception handling in the top, I can repeat the same logic. Instead of doing directly, I can write an @ symbol in the top. Sir, can I use both of them together? I pass an argument and I don't pass. That doesn't work. You can go for either this syntax or this syntax. So which one is more comfortable as an end user? The second one, because you need not worry about what is happening. You can just use your function like an ordinary function itself. Whatsoever things are there, it will handle it. See now? So if I mark like one of them as a string, so if I mark this one as a string, so in all the cases, it's gonna work. Perfect. So what you learned in this particular script is about this syntactic sugar. So how we are making the things better. Now let's go for the next one. After the syntactic sugar, let's implement for a different example. Say I have one decorator which is helping me in terms of the prints. So how prints will help? Let's see. If you see in this example, I have one function which is having some print function in the starting, and it is doing the addition, and again it is printing that function before ending, and it is written. Similarly, I have one more function which is executing the similar thing, but it is doing a multiplication. But before, in the starting and at the end, it is printing the things. Did you see what is common in both the functions? The print functions. If you make a call, it will execute perfectly. Clear? Python 04. Second, I think it. Yeah, decorator for print. Yeah, see here. Clear and Python 04. Yeah, see here. In both the cases, it is working. So before and after, it is making a print statement. That's what you have seen. So now, without changing the logic, we want to take the common code which is executing. Means we are not making a performance improvement with the decorators, but we are making the code to better reusability. We want to reduce the redundancy in the code. So for that, how we can do? So what we understood is that some function is executing before and after. For that, we need to do. So now for this, how do you create a decorator? See, so for creating the decorator, so I make the decorator function name as print function because it is doing the print. For every decorator, first argument is a function. So next, within that, you define a inner function. For inner function, you can make any name. It doesn't matter. So star args and star star kw args. This is the standard format. And within this, we need to execute that function with the given arguments. Sometimes you want to get the result, then you can return that result. But did you observe here one pattern? Before execution and after execution, it is making a print function. So now if I say like print, and here also I am returning. But at the end also it is having a return. But if I do like a return after that, sorry, print after that, does it make any sense? No. So instead of returning it, what you do, you make a result equal to, then same like the above, and finally you return that result. So in this way, for everything you are executing and finally returning it. If I now make like an inner as a return, now did you see I created a perfect decorator? Observe carefully. Now the same function I want to execute. So I know the same logic, why you need a dependency. As I implemented this decorator, I want to slim this one. So instead of doing these things, it can just do what is its work. As this result is just for printing, there is no point of having this also. You can make it to do like a simple return. Return this one. Similarly, here we can say return this result. Now, did you see this much logic was reduced to just 4 lines? So that is the beauty. So we can reduce the overall time. Now, if I give the same function without changing the functionality, I get the same answer. So I get the same answer without changing the functionality. If I execute, you see here, what are is doing a print and above and others, it should do the same thing. But for the second case, you are not getting the print statements. The reason being, you create a decorator, but you are not registering them. You need to register like this. The moment you register, then if I execute, did you see in the second case also you got it? So that's the point. And if I go like one step ahead by enhancing this one, so instead of just doing a function start, so we can better say like which function was started, right? So for doing that, we can comment this one and make a slight difference. I told functions are also like a first class objects. Those are also having an attributes. If you use the underscore underscore name, did you see now it is much more clear? Addition function started, addition function before end, multiplication function started, multiplication function before end. So now things are much better, right? So this is one more example about the prints. And the most common example of the decorators is about the retry mechanism. Retry mechanism means what? Whenever you have some logic which is not executing, so due to some reasons, timeouts or something, you want to retry the execution. Say you want to retry for some times. So for that, I can create one function called as a retry. So every time a decorator will take the input, and within that you can define a inner function which can take the args and star star kw args. Like this we can take, and within that you want to execute for some amount of time. Say for so I in range of say 3 times you want to retry something. So you do like a func of star args star star kw args. So means like a function, if it is failing, you want to retry. So repeat is different from retry, right? So if it is like a repeat, you can just execute. So this is like a repeat. If I say repeat first, I will do. I'm taking this one and within that I'm executing this function. Now if I say return inner function, it will execute. Now if I make a call to this function, so generally if I have a function called as a hello world, then what will happen? Clear run Python. So 04 B7. So did you see? I got a hello world. Now, if I make this repeat decorator, now if you see the same answer, in you executed once only, but it is executing 3 times, right? So hope you understood what it's doing. So maybe I want to retry now. Retry mechanism means whenever it is failing, you want to retry. So for that, I want to implement one more thing. So means like this time, I will create one more decorator called as a retry. So retry. Retry means what? If it is failing only, we want to execute. So I will do like a try. So I will say like a result equal to. Hope you remember the scenario. So I do the exception handling. exception as X. So you want to maybe print so X and you want to retry it. So you don't want to do any logic. Maybe here itself we can do like a return because I don't want to do anything else. I just want to return. So you see here now, it's a simple logic. It will work like this now. Now, if I assign the same thing to this hello world, does it work multiple times? No, it will execute only once, right? So if I make an empty print, if I execute, did you notice it is executing only one time? Because it is successful enough. So what if I introduce some kind of bug? So then it will fail, right? So maybe like I am executing something where every time it will fail. So instead of a print statement, say I do like a for I in range of 2 times. So you want to raise, say, zero division error something, and subsequently you want to print it. Observe, very interesting point. If I do like this now, for this one, I did a retry. I am trying to use. If you observe now, for all 3 times it is failing, right? So if I do 2 times, what do you mean by 0, 1, 2? So 2 times it will fail, and you got it. It is handling exception every time and doing. So maybe like if I do it for like 5 times now. So did you see now if I do like a 5 times? So this is doing the same thing for 5 times. It is handling. So means every time you make a call, it is failing for that much times. It's not going to the next one. So for the first time you are calling itself, it is failing itself. So, but like if you want to make it much better. So now if I want to a decorator with some arguments, decorator should take some values and it should execute. Till now you didn't create a decorator with arguments. So maybe if I want to create a decorator with arguments. So this is the standard format for creating any decorator. Outside function, func, inside function, arguments, you do the execution. Now here if I define, the retry function is taking 2 arguments. Then within that I can write like a inner function. So observe carefully, this is inner one, which will take the function and which will have one more inner called as inner 2. In fact, the inner functions you can name anything because no one will call the one with the name. So did you see now logic? And within that you are executing your things. Say like based on the environment and the count, you want to execute for that much times. So what are the environment we are given? Now if you see when you are making a call, instead of earlier like just a retry in the top, you can pass the arguments also. So if you pass these arguments will go and it will be done. So fine, it is working. So similarly for UAT, if you want to do count for a different amount of times, for UAT, I am calling that much times. So it works like this. So this is what I want to prove. So they also can take the time. So and like that. And this retry is like typical retry. So, but I want to give like one professional example of a retry on failures. So I will write the logic. Just have a look at it after this call. So you will understand. You see in this example, this is a professional code for retries. So retry on failure. I did like much better way with the try exceptions to handle it, to handle the things. So just walk through it. This is like a retry on failure. I have an inner function and a wrapper. Earlier, I needed 2 retries. I did like inner 1, inner 2. But I did like here wrappers. But see, when you have an arguments in the outside, this func will go to the one level down. And you see here, it is working. And here I made use of something called as non-local. You remember? If I want changes only to one level above, not to the outside at the global level, then I can use non-local. So that is what happens. Next, if I go for one more example about the time taken decorator. This is also most common used decorators. whenever you are using. Means if you want to calculate some time. So in Python, there is a module called as time. So time is a module to get the performance time. So if let's say if you have two things happening, how do you calculate total time taken? Say someone is running. Initially, you will start the stopwatch, means you will measure the first time. By after completing the entire logic, you will check the end next time, right? So generally, everyone will do the same process, no matter what logic is. Initially, I will mark what is the starting time, and then we will execute some logic. And finally, we'll take what is the time at that time and compare both of them. That is how we calculate the time taken by anything, right? So it took like these many nanoseconds, it is saying. If I execute again, it says something around the time. Now, so instead of assigning the second value to something, we can also do immediately. First value, we need a timestamp. That's why you're assigning to variable. Second one, directly you can execute and compare the difference. So generally, if you go for any of the time logics, they will do like this only. Now, if I want to create a time taken decorator, so we can do simple. So what we can do, time taken decorator means, first I will take it like this. So I will mention like time taken. So which will take the first argument, which is a function. So within that, we need to mark this inner one called as a wrapper. So we need to write whatever the logic we want. And finally, we need to return that wrapper. So this is what the logic we have. So within that, what we want to do, what are the function you want to execute? We want to execute star args, star star, kw args. If I assign that to one variable, and we need to return that result. Now the point is, before execution, I want to print it and say like how much time it is taking. So, and after that also I want to execute. So at the end, you want to do what? You want to calculate the total time and you want to display. So now you see here, I created the started time and like end time. Between that, I'm doing the logic. So don't you see, I created a small decorator. So now if I do like, some function and I registered this time taken to that. So this function is like, I'm registering the time taken decorator. I'm doing some logic. If I give some number, it is looping for that much time and printing. Now, if I do this decent job, I'm getting this thing. So for 78, so it is taking this much times. So instead of just printing like it is executing for some time, I can do like a better way. Say, you see in this case, I'm writing like time taken is something. So now it is much more clear, right? You see, so for this 78, it is taking this much nanoseconds. So for 900, this much. For 9,000, it is taking further more time. So how much time it is taking each time? So that's we want to print. And observe here why it is taking every time the negative values. Because instead of assigning to some variable, I am directly doing. So here, if I assign to some variable, now it would be much better. You see here, I have now assigned. Now it works perfect. So it is increasing, right? That is how it works. In the same fashion, so I can take like multiple other logics and ask like how much time it is taking. So this is how I place it to different functions and trying to execute and ask. So like that, these are the real-time use cases. And the last point I want to mention is about like, what if you have multiple decorators on the same function? Till now, I told about decorators, decorator which take arguments also. But what if you have two decorators and you are applying? So till now, I told about the time taken decorator and also the print decorator. So now if I'm applying both of that, what will happen? So this Python execution is like a typical top to bottom and left to right execution. In the same fashion, even decorators also execute in the same fashion. So first it will go to the time taken, then it will go to the print function. So then and it executes. So when I execute here and Python 06, did you see? First it is going to the print. So because print is the law inside. So the order is like this. First it will go to the time taken. Within that it will go to the print and it will execute that and then come back. So first it will go into the print. So because that is the inner, and then it is going the time execution and you are getting the result. So this is one way to execute. And also one more example for you to understand is, this is a very clear example. Let me take this one. If both are doing two different actions, you are not noticing much difference. But what if I place two dummy decorators which are doing the same job? Means if you go to the first one, it will say I am a decorator 1. If you go to the second one, it says I am a decorator 2. But it will execute the same function. So nothing to return. I have a decorator 3, it is saying I am a decorator 3. Now observe in this case, I have 3 decorators applied and see how it will execute. So I think with this, we will get a very clear understanding of what exactly is happening. So did you see now what is the order in which they are executing? So first decorator 3 logic is executed. Next to decorator 2, it is executing. So decorator 3 is executing. And when completion also, they will go in a reverse order. So, so if you say like, start off. So instead of I am, so start of decorator 1, if I say here. And if I say end of decorator 1. So here also if I say start of decorator 2, and here if I say end of decorator 2. And similarly here also if I say start of decorator 3, and here if I say end of decorator 3, if I have like this. Now if you observe, if I execute, you will understand. The order in which they are invoking is like this: start of decorator 3, because that is the order you give. Start of decorator 2, start of decorator 1. And actual logic happens. And in the reverse will happen when the completion is happening. Did you see? This is the beauty of this one. So this is how you understood the order of the decorator executions, how they can help. And so similarly, one last point I want to mention about this decorators is decorator function as an argument. So I told you already this one. So sometimes you want to take this one. See here, this is a very practical example. You want to calculate the time taken, but in which measurements you want to do? Is it in milliseconds or nanoseconds or something? You can pass this argument. Earlier I showed you 2 arguments. Now here 1 argument, like that. So one more example, just walk through. And yeah, this is one interesting point. Whenever someone is working on the decorators, they'll be asked about this functool wraps. So means like, let me give one use case. Till now, let's think about the functools. In functools, by now we used a lot of functionalities, right? So this is one more function we will use right now. To understand the purpose of it, let me take. If I take an ordinary function, this function has a docstring also. We can specify. When you're making a call to this function with true, you will get whatever is the result. Similarly, if you ask this metadata about this function, it will say what is the function name and what is the docstring. If I ask, hey, what is the function name? As it is f is a function name, you got f. But if I ask, hey, what is the docstring? It's saying like does some math. This is fine. So every function will have this functionality. Now, let me take this thing where I am defining one decorator. So using that decorator, I want to execute. So see here what I'm doing. I created one decorator called as logged. Within that, I am doing some name with logging, but I'm returning it. Then becomes a closure, it's a decorator. Within that, I'm writing some statements. I'm asking to print its name and the docstring. And I have one function, the same function with all these details. Now, the same way I'm asking this call means, so as we cannot make a direct call to this f, I need to make a so indirect call by passing to this decorator and executing, or like placing the decorator symbol at the top. Either way, it works, right? So first, traditionally doing by passing this as an argument, and I'm asking. If you see right now, I'm asking, did you get what happened? If I ask, hey, what is the name of the function? It says with logging. So if I say, what is the function name? F. It is saying like with logging, the inner one. And if I ask, what is the doc strings? What is the doc string it is giving? Doc means with logging doc it is giving. Did you see? Your main function doc string is not coming. It should actually does some math. In this case, what it does some math it is showing, because that is the main function. Now, instead of your main function, the inner function's docstring is coming. Okay, sir, because of the syntactic sugar, maybe. Let's try the other way. If you ask, let me try the same thing again. This time, if you see, I did that the syntactic sugar and I'm asking, and this time I'm making a direct call to this F. So at least this time it should work, right? You see, now this is also problem. Even if you are asking in this way also, after doing this, you are not getting your doc strings, but you are getting a different doc strings. So then, sir, what is the problem? How to address it? So for that, if I go further, so if I do something called as functools.wrap. So what is that we need to place one more at the rate symbol and do it. So this is same like your decorator. Apart from your decorator, for the inner decorator, we need to write this one line. This is by design. If you write like that, then you will get the entire doc string. So what is the limit? So let me show you that result. Did you see you got it? Means I simply to conclude, the functionality will be same every time. But the only problem with ordinary decorators is that they will not retain the doc strings of the original function. Whenever you're very crucial in terms of the doc strings for usage and others, then wraps of that particular function is needed. Means what are the function you are passing as an input that you need to pass, and we need to do the wraps decorator. This is one thing you need to learn. So this is not mandatory, but it is like one of the points that you need to be aware. So both in terms of interviews or whenever you're creating doc strings also. So similarly, wraps I told you in like different examples. And the last thing is, these decorators are not just confined to functions. In future, you will do about the classes. At the time also, you can remember about it. So if I take this example, if I want to have one class as a decorator, you till now didn't work on classes, but in future you will learn. In classes, we will have something called as constructor. Similarly, there is something called as underscore underscore call. So if you write that thing, then you can execute. So did you see that this entire class you are placing like this? Class itself you are passing as an argument. Class itself I am passing as an argument. Sir, in which case we need to use? Whenever you have a decorator which is having not just one variable, sorry, one small logic, but some kind of state management. A simple example where I created like this is when I gone for like, middlewares. If I have like a web application, if I need to do the user analytics, so then I need to have some kind of class which can accept and store the state and other things. So in that case, we can use it. So means decorators are not just confined to this. In the same fashion, if I go decorators class as a decorator, as I told, this class also can take the arguments. So in the previous one, we have seen a class decorator which is not taking any argument. But you see in this case, I am taking here as an argument. When you understood classes, you will understand what is a constructor, how the arguments will be taken. When the constructor is having one variable, you can pass that also. It works perfectly. And on top, if I want to work on the, say, method as a decorator, so means like within the classes, we have some concept called as methods. Within the classes, we have something called as methods. If I take this example of a methods, you will understand that. So simply to understand, You have created an ordinary decorator. You see, outside and within that a inner function, you did it. So for earlier you created one class as a decorator and use it for your functions. But now for in a class, for a single method, you want to place a decorator. So like that also we can use decorators. So these are all the different functionalities you will learn down the line. So, and we can use. Now coming to the examples of and assignments. One good example I want to give with this is about the phone number formatting. So what I want to take is like, you should write a function. So I just want to write first and I want to delete it. Say like I am writing a function. So which is taking like any of these numbers and it is trying to streamline it. Say clear and Python 13. If I say, did you see no matter what numbers you give in different kinds of formats, it is trying to streamline it, right? Say you want to do some kind of sorting the numbers. If you are given some kind of four numbers, you want to sort and print. Did you see I sorted and it is a list. I want to print them individually. Then I placed a star before it. This is very interesting. In fact, this is one of the interview question. So what I did before sorting, first we need to have them in a proper order, right? If numbers are like this, you cannot sort them directly. For doing that, I am writing a wrapper. So this is my wrapper function, which will do the formatting. So within that, I have an inner function, which is doing some logic. So which I don't want you to do now. I want to take it as an assignment. So I'm doing like a pass. So complete the assignment. So you need to know how to write the logic to make it. For understanding how to do that, you need to know what is string formatting, what is the conditions and others. So the next point after this, I think like typically I told about all of that. Yeah, this is the last one I want to touch base. There is one built-in decorator called as LRU cache. So this is one of the most important things whenever you're working with the caches. Cache means what? Whenever something is used more frequently, we will store. When you're storing also, there is one particular order. So one of that order is called as a LRU cache. So what is this LRU cache means? It will help whenever you are working on this one. Say the least recursively used will be deleted. So means when generally most frequently used should be placed, right? But whichever is least recently used, that should be deleted. So that is what everyone says. LRU cache says the same. So this LRU cache, we need to implement it. So how we are implementing is a concept. Instead of you implementing the entire strategy, so it was already done for us. Like few built-in functions we did. So functools has having that one already. So let's say you are doing the Fibonacci series. Hope you have done the Fibonacci series assignment. You will understand. For every number, we need to calculate the previous numbers. So this is what we need to do every time. So if some of the results are there, means like say Fibonacci 2 is there. For Fibonacci 4, we need Fibonacci 2 also as an input. When you're doing a recursive call, means Fibonacci 4 will call further Fibonacci 2. So whenever it is calling, it will be optimized because it is already there. Similarly, if you go for Fibonacci 8, which will already take like Fibonacci 4, means whatever the results, it will register a function with this name, argument. If the same argument you are making with that function, it will be cached. So when you're making a cache also, how many values you want to store, you can present that. So it will store that much amount of things. I say clear and Python. So 17. So did you see calculating the values? And did you observe that in the first case for 2 need like 210, right? But when you go to the fourth one, so it should take like 4, 3, 2, 1, all the values, but it is taking only 4 and 3 only. Why it is not taking the first 3? Because it is already storing. Now, if you go for the next one, what it is doing? So 8, 7, 6, 5. But for 4 and 3, it is not taking. Because 4, it is already there. Assume that if I don't have this cache, then what will happen? If you see, for each one, it is calculating everything else. So, and it is failing here, saying that you don't have a cache information. But if I have this one, so we are reducing those number of calls. So this is one kind of code optimization strategy. So this is all about the decorators that I want to say. So there were still some kind of advanced concepts, but I don't want to touch that. So I think this is fine for these decorators. So the next thing that we will learn is about the iterators, generators, and coroutines in the next class.